Good morning, good afternoon, good evening, everyone. So, welcome back to codingscientist.com. So, guys, in this tutorial, in this particular video, I'm going to show a demonstration of a gesture recognition on the humanoid robot which we built. You had seen an introduction about the entire humanoid robot in the previous video, and the subsequent large language model that is on based on the computer vision area which we built and deployed based on that model and on robot operating system. So gesture recognition is one small feature of this entire robot, right? So basically what's going to happen is the entire the process of gesture recognition is basically by capturing live footage through the robot's camera, which is like on the head, right? And then the image processing basically happens on the OpenCV platform. So OpenCV is one of the open source library for computer vision which we used in this particular project, which includes basic operations such as blurring, erosion and dilation, and so on. Subsequently, the processed feed is input into the hand recognition model, which is another model which we built. It's a pretty simple machine learning model which we built to identify and mark the palms, the areas of the palms. So the camera actually recognizes the palms and it makes the marking as well. So these recognized palms are marked and the joints on the palms are connected to each other with lines representing the knuckles and the mark points indicating finger joints and fingertips, so and so. So you can actually play around with this particular machine learning model. So these lines are basically mark points, and then when you move the fingers left and right or any other, so the joints actually triggers another action, subsequent action into the robot. So the gesture recognition is basically achieved by analyzing the angle of each fingers and determining whether they are bent or straight or round or circular or whichever way it is, right? So based on what you want, actually what you need the robot to do, based on the recognition, you can actually modify your Python code on that. So let's look at a simple demo. I am going to switch over my camera to different angle. I hope you guys can see. So that's where I place my bot. I am going to switch it on now. It's currently in a charging mode. I hope it boots up. So this takes about 30 to 40 seconds to boot the entire system, because it's working on Raspberry Pi 4B, and of course there are a lot of backend services which needs to be triggered. One is the Python and ROS and the vision action model and stuff like that. So it takes about 35-40 seconds to boot up and the robot will stand. And then I'm going to connect through its internet, and we will take it forward from there. Just give it a minute, guys. It's booting up. It should boot up now. It should boot up any second. As soon as you hear a beep, it's going to stand up. The bot is going to stand up. Alright, that's the beep. It should stand up now. I hope so. Come on, get up, bot. Stand up. There you go. Alright, it's going to adjust the posture. Alright, now it's pretty much steady. So I'm going to connect to the robot's Wi-Fi internet, which triggers from the Raspberry Pi. And once I connect to that, I'm going to connect to its local network. Alright, I'm connected. and then I'm going to open up its Linux platform. So basically connecting to password, I am able to, oops, okay, there you go. So I am able to boot up the system, as you can see on the screen on the right side. So I'm able to log into the ROS master of the humanoid robot, and then I'm going to initiate a couple of commands. So basically to initiate that particular code of hand recognition, let's see. So I need to initiate sudo system control, sudo system control, and then let's stop and start. So basically to start the services you need to first stop and then start the app again. It's like rebooting, you know. Start underscore app underscore node dot service, hit enter. Okay, and now I am going to run the ROS topic for that particular hand gesture stuff. ROS launch, ROS launch space underscore example space and underscore gesture underscore node underscore node dot launch. It's a pretty lengthy command, but yeah, you will get used to that. Alright, it's booting up the camera. There you go. Okay, cool. Now what we need to do, I am going to open up a browser and then put in the robot's IP address, so which is basically going to open up the camera. Let's see. So it's basically 192.168.149. So alright, there you go. I'm able to see most of the stuff on the browser, but I need to activate the camera and see how it works. Okay, and there you go. It's able to see, the bot is able to see me actually, so that's me. So I'm live on the camera. So can you see it's recognizing my hand from the robot? Let's see what it says. Wow, there you go. So if I show 2, you know, it just twists. That's the program being done. So basically you can modify this program according to your hand gesture what you want. Now if I say 1, let's see what happens. There you go. It says hello. There you go. It says hi bot. Let me say 2. It has to twist. There you go. Fantastic. Let me say show 1. Let me say 1. There you go. So can you see guys the dotted lines on my finger, and that's the recognition from the robot's facial camera. That's on mounted on the head. Excellent. Now two. Okay. Wow. There you go. Excellent. So looks like it's a pretty interesting stuff, guys. So you had seen a short demo of the hand recognition, how it can be triggered through ROS robot operating system and the vision recognition models, machine learning models, and deploy that on a movable machine. That's a humanoid robot. Now it's not necessary that it has to be a humanoid robot. It can be any kind of robots you are building. So anyways, guys, so this was just a short introduction about hand gesture model, how you can deploy into a humanoid robot. So I am going to come up with multiple other short demos on multiple features and research oriented projects, what and all stuffs you can build using this bot. I will see you soon. Goodbye.